so what I got is from the University of Boston University. Actually, I always thought it was the University of Boston, but
well, there's two. There's Boston University and there's Boston. Is there? Oh, there's Boston College, and then Boston College, and then BU. Yeah, and then there's a UMass Boston. Right. And then there's UMass Amherst.
Must be like our student system must be the equivalent in terms of how confusing it is.
Yeah.
Yeah, well, so the really confusing one is Buff State and University of Buffalo. In a matter of miles apart. But Buff State is a dinky little thing. It's kind of like SUNY Canyon. And then the University of Buffalo is the University Center. So that's completely different.
Yeah, UB's.
They hog up almost all of Amherst. And then the other strange one is, like this one. There's Alfred State and there's Alfred University. And Alfred University is private and Alfred State is SUNY. But just to make you have some more fun with this, there is a ceramics program at Alfred University that belongs to SUNY.
What?
Yes.
So they use each other's buildings a little bit?
Oh, it's just weird. And the worst part is, the only thing about Alfred that actually has any purpose in life is, it's a road going down the center. There's a hill this high and a hill this high.
Yeah.
Alfred University owns this hill, Alfred State owns this hill. You think going up and down the hills here are bad, that one you actually got switchbacks to walk up the hill. It's like,
I went actually, yeah. And in like the first 5 minutes where the president comes up and talks, and he's like, "We're proud to say that the only stoplight in town is in front of SUNY Alfred, not Alfred University." It's like the only stoplight in town. Oh boy.
Yeah, that shows how big the town is.
to bring fast food in, Alfred State actually brought in Pizza Hut, Taco Bell, basically Kentucky Fried Chicken. That was the fast food joints. And people from town would drive on the campus to go to the fast food.
Did you hear about I think it was one of the kids up here, it might have been SUNY Canton. It was one of the 4 colleges up here, but they booked the plane tickets to New York City to get Chick-fil-A and then flew back the same day because it was cheaper than driving.
Wow.
Like, they had enough people that, I think there was like 6 or 7 people that were putting in money for it, so they all kind of just split it, and it was like $20 a person for the plane ticket for one person to get it all, and then they just flew back. Like
Unbelievable.
Hours, 3 hours.
Okay, so we're going to take a look at this design project that Boston University did, or these 4 students at Boston University did, and we're going to redo it and verify their numbers. What I'm really interested in that we finish between now and finals week is the shaft that I just circled there, okay? So we got the 1 gear, and we got bearing support, and then we got, we gotta make some choices, because I'm not sure they did, but in this area right here should be probably a retaining ring, and then we gotta figure out the bearing at the other end. So when we get done, we really got a shaft looking like this, with a bearing here, bearing there, and a gear like so. And then this little shaft out here, it's got its mating pinion. So we'll design that along with this. And that'll give us the gear design bit, the shaft design bit. We'll be able to pick our tolerances. We can deal with keyways, and we can deal with rings. So it should be a culmination of pretty much everything we've done and make the world a happy place. Make sense? Okay. Laura, you good?
Yep.
Okay.
Yep.
So I got a paper copy here for you, but right now it's here, and actually that's what I was going to do, but then I spent too much time frogging around the office.
Let's get this out to let's put it in handouts. You want it in homework? Oh.
I'll be asking a question.
I just saw a thing that looked similar. Curious on what's
Okay, so that'll be in your files. So literally, Laura, if you click down on here and give it a second, it'll appear right there. So everybody's got it electronically too. Okay? Cool. Makes sense? So really it's not any more real teaching, it's more about picking this thing apart and trying to figure out what the sizes are supposed to be, and you guys calculating some numbers to go with it. So let's delve into it. So our four friends here designed this. We got a gearbox that's required to have a ratio of 1 to 240, a minimum life of 2,500 hours or 25,000 hours. The input and output shafts are orthogonal and a maximum of 1.5 inches past the outer surface of the gearbox. The output shaft is output shaft and its bearings must support an eccentrically loaded 50 pounds and have a maximum input shaft rotation of 240 RPMs. All right, so we got our RPMs now, right? Orthogonal and max. The input and output shafts are orthogonal.
Orthogonal?
Yeah. Does that look like all like eight-sided?
Maybe six-sided.
It's hard to tell on the paper picture. It's not even that much clearer on here.
Looks pretty hard.
Orthogonal.
I think it is.
Yeah, I guess if you look at the end, it does look like there's a little bit of a
Yeah. It doesn't look
some sort of
right.
X or something.
It would make sense that there is a, well, every shaft when it drives has to probably have some teeth. Like so. I missed a tooth in there, but basically a drive system so that there's a coupling that slides over, but that's the only thing I can think that means. It sure hell doesn't mean that it's an orthogonal view. And a maximum 1.5 inches past the outer surface. So our bearings out here, from here to here, have a max length there, okay? All right, final design of the project includes a 10-tooth spur gear and a 100-tooth spur gear, one worm gear, and one 24-tooth worm gear. We're not going to worry about the worm gear, but we are going to go work on that little pinion gear out there. Gives us a ratio of 1 to 240. The orientation of worm gear makes the input and the output shaft perpendicular. The input and output shafts both protrude 1 inch from the surface of the box. So this is the input shaft here, the way I'm reading this. Everybody agree?
Yeah.
Okay, and that's going to drive down here and then drive this and drive our output. And if I get a chance, I'll talk about
shaft couplings so that you can see what those look like.
So you can see those. The input and output shaft, 1 inch, you don't have to worry about that. All bearings are supported. All bearings are specified to support 50 pounds eccentric loading with a maximum speed of 240 RPMs and a lifetime, blah, blah, blah. Okay, so we'll go actually look up some bearings too while we're doing this one and choose some things. Our gearbox is made out of 304 stainless steel sheet metal. Cool. 2 parts, 1 part. We might modify that a little bit to make something a little bit more plausible. Hey, that reminded me, did Tim log in today?
No.
Can you ping him, Mike, and see if he's out there on the planet? All right, so here's their equations they did. We're going to check them with ours. And there's the spreadsheet that they did for the input shafts. So we'll run and check their numbers. Basically, we're going to redo their design as much as possible and check their numbers and make sure it works. Or actually, I should rephrase this. You guys are going to check their numbers, and I'm going to guide you along. All right. So cool. So let's ask the $100,000 obvious question of nowhere. What's the first thing we want to know? Where did I just copy that to? There we go. Okay, so what's the first thing we got to do here? He's actually showing up, or is he remote?
First thing I want to do is find their gems if they gave that.
Okay. And that was what number? I just read it, didn't I?
240.
Yeah, that's pretty cool. So we're actually using a 1 RPM to 240 RPMs. Interesting. Okay, so we got that. Next piece.
Find the torque in the system.
Okay. So in order to find the torque, what do you have to do?
Oh, we need that horsepower.
Get a horsepower. And the other one. Yeah. Go into the horsepower equation.
was 63.
63.
Yeah, 63,000 times the horsepower divided by torque.
Right. So we need a torque, don't we? So let's introduce another favorite friend of mine here.
There's stapler in there? Oh, alright.
I wouldn't bet my life on it, but I'd kind of hope there would be. But if not,
Yeah, I suppose.
I'll take it the way it is. Guys been here before in your lifetime?
A couple of times.
Not very good.
Once it closes.
So when in doubt, of course you're not going to give it to me. Alrighty. Some days these guys have gotten a little too into themselves. They used to be really just simple. But it's kind of there. So they don't have anything at 240 RPM.
Extrapolate.
I would say yes, or we could cheat and modify this problem any damn way we want. What if we crank it up to 500? Okay. Now, so there's your first modification.
So we're trying to improve this. Is this like their report and we're going to improve it?
We're going to take and design similar thing, yeah. But we need someplace to start.
Yeah.
Okay, so we're going to sue 500 RPMs. Okay. Go back to our table here. We probably should take a look at probably 10 horsepower. Seems like a good number. Okay. Make sense? All right, so we're back over here. Okay. Cool. Now what?
Now I found the torque.
We'll find the torque. Cool part was, what they give us on the table.
Yeah, it gave us all that.
And if we get the torque, what are we going to know from that?
I've got like 10 things going on.
That's what I was just
right now.
thinking.
They're talking about that. It's not my brain.
He's going to grow up someday and he's going to have all these things all over the place.
You should have seen my desk. Like 40.
Well, what's we saying? You get like a house or something, it's gonna be pretty scary.
So if we got the torch,
Um,
what's the next thing we're gonna need when we get to the gears?
their locations.
Well, we gotta come up with a location for the shaft we wanna put it.
Yeah.
But we're gonna be able to get the force if we can determine what our radius of the gear is, right?
Yeah.
Right.
We need the force tangential and the force radial. And we need to make some assumptions on our gear. It's easy because the textbook gives us 20-degree pitch angles. So let's use 20 degrees instead of the world. But along the way, we can actually go out and take a look at our favorite catalog. I don't know if it exists anymore. You look it up. Boston Gear catalog. Boston Gear. Pretty sure they do because they're famous. We can go out there and actually pick their gears. And we can pick the shafts size. And then we get to design our shaft. We're going to be able to design a shaft. Either have rings, shoulders, or shoulders and rings, or can't have two shoulders. It just doesn't work. You could if you could figure out how to put the gear in the middle that casts around it.
That's bostongear.com.
Okay, so cool part is look at that. Look at that, enclosed gear drives. Bearings. So we should be able to get all our parts out of here.
Are we gonna actually like make it into the real world?
Do you have that kind of time on your hands?
No.
Yeah. We're just gonna run the numbers.
I figured I should ask.
Yeah, that's fine.
The winter, I've got that kind of time. That's
Yeah.
part of the year, I know.
Well, honestly, I thought after fighting for better parts since Saturday this morning, I'm trying to get these stupid inventor files open from GradCab, which promised, oh, all the files you need. Yeah, all the files is there. They don't work. Like, inventor just sucks. Then I had to fight with getting inventor 22 now, because I had inventor 21 was out of the license. It's like, then I figured out that Autodesk is stuff space.
Yeah.
You clear any old files out of there for the last 3 versions I had. It's like, you got to get it. I had to delete all those. So anyways, first step first. Get your paper out, let's do some calculations. Let's get some numbers here. And then we're going to figure out what gear we're going to pick. They didn't specify anywhere in this report what the shaft diameter is going to be, but we can set that. Mike, you can figure out if there's anything in this valuable?
There's an Arduino in there. Other than that, probably the most valuable thing is breadboard, which I stole. Well, it's right here.
I paid for them. It's not mine. Breadboards I got.
I noticed, I opened the cabinet over there, you got like 40 little teeny ones.
Well, and I got the big ones with the different power supplies on them.
Yeah, I would have liked one of those.
Laura, are you following along? So you're going to calculate the numbers here. And eventually you're going to write this all up into one nice set of comp paper. Today you can scribble, I don't care. And if you need me, you got to holler.
Okay. Okay.
'Cause
Okay.
I can't see the OneNote screen. Mikey can, but you know, he's also playing with a bunch of little projects for credit at the same time.
Yeah, I've got, this one with Arduino, he wants me to play with the second. So I got that one pretty much set. He wants us to do something with linear actuator. Oh, yeah,
Is this all for your Mechatronics class?
yes, and then this one is for 3D printing. He gave us the thing, he wants us to launch essentially a marble, 3D printed marble, as far as we can get. Whoever does it gets more points. It has to be exclusively 3D printed. So I can't use glue or rubber band or anything like that. So I printed out some stuff. I found a design that I think might work if I alter it.
Are you responsible for the silk purple prints up here?
No, that's Jared.
This is what I have. Just that we adjust the RPMs.
So I found this model. I said, okay, we'll make 3D form. So I said, okay, I'll print that. Where's the till broke?
So, wanted a 3D printed spring, and
Yeah, pretty much. This spring right here.
Let's try to make it trailer shack.
Well, that's it. It has to fit within 6 by 6 by 6 inches.
okay.
And,
Why am I having you do design projects then? Never mind, shut up on that. That's what.
I mean, if you guys want to,
Let's find some gear radiuses that will work.
Okay.
And then I printed it in resin, and now, of course, all the stuff is too precise, so it's way too tight, so it won't spin.
Now you can sand it.
Yeah. Because it's supposed to just ride smooth.
Cool.
What was the size and constraints on the D-box? Were there any?
They had. Where'd it go? Our gearbox is made out of 303 stainless steel sheet metal that is 0.060 inches thick. There are two parts to the housing. One part fits the other, connecting to self-cinching nuts. Blah, blah, blah. And they didn't really give dimensions on it. So it's okay. Let's try it within, keep it smaller than 12 inches and no smaller than 6. So 12 inches to 6 inches. So I do this.
Taking down these numbers, the 500, that 10,
What's that?
but I guess I'm confused as well. What I'm supposed to do.
Well,
I'm trying to find gear sizes that would work. The problem is that the bearings can only hold 50-pound piece.
let's try that way too. That gives you your width of gears you can play with.
I don't think we're gonna be able to keep it to 12 inches if we keep the bearings that they're specified support.
That's okay.
Okay. Because right now I'm getting, if we max it out at 12 inches, you're at 105 pounds of force. And if each bearing can only take 50, and it were perfectly distributed between them.
So let me ask this: 105 pounds of force. Is that your tangential force? Is that your radial force?
Sure. That would be
Because remember, your radial force is coming in from the top.
Yeah,
So
that would be your results.
you're, yes,
I was just taking that torque and multiplying.
your
it by
gear
3.5.
is this. So you got a torque here. All right, it was 1260. Yeah. 1260 pound-inches. And you did a 12-inch radius.
Yeah, I just maxed it out to see without giving it an idea to base things on. But I didn't look up the equations for the tangential forces.
Right. So that's okay. I mean, so what I'm actually after is not so much that you, well, I want to calculate the right numbers. What I'm after is that you understand the nightmare that is of design. You know, so this final project is not about the things we already know how to do, hopefully. It's about how do you take those and use them in a design. So I gave you some parameters, 12 inches no smaller than 6. Okay? If we do 6, okay, what's that do to your forces? But I want you to remember what you're trying to piece together in your head and sort out for yourself is that is your force tangential, that's your force radial, and that's your 20-degree force that's there, okay? But your torque, this force right here, is T.
That's tangential.
So that's not your radial force. So that's not the force that's actually on the bearing. Okay? Does that make sense? Now, are you with me here? For you to follow along on all the stuff we did the last couple of weeks? Yeah. Okay. All right, so what can I actually support now if it's 12 inches? And we can always make it bigger. I mean, that's the beauty of design. Our real goal is to get 10 horsepower transmitted from point A to point B. How do we do it? I've just used these guys as a starting point. If I really had the spare time in my life, I would have sat down and designed this a bit better from scratch. Once upon in my lifetime, I actually did that stuff. It was fun, relaxing.
Yeah, that's more reasonable. Your tangential force is 38 pounds.
So we're okay there, right?
Yeah, which in that case you probably think about going a little smaller just because you putting it right against the maximum kind of makes things a little tight.
Yeah. So
when it comes to actually building.
yeah, so does it really have to be 12 inches? No, it could
No,
be
so probably go to 10 or
try 10. I mean, so this is the beauty where a spreadsheet kind of helps. Right now, this is the part of the design where you're just kind of getting yourself started, and this is where I tell people, it's like, get out a blank sheet of paper and you sketch. I want a 12-inch radius, or a 12-inch diameter. All right, so the house is going to have to be at least 12, a little larger to get the space for everything to swing. Then I'm going to figure out what my gear is before I actually go put it into CAD. Once I get it in CAD, I'm hopefully at the point where I got the right dimension. And the other bit of this is, remember what I said in the beginning, most of machine design is about shopping. So when we decide that it's going to be a 10,
then you go.
we start looking for a 10-inch gear. Okay? That means you got an opinion that's going to drive something else.
Okay, and it's got its bearing. You're not wearing the camp hockey sweatshirt today.
Oh, I had one on yesterday.
Saw Lucas and Ashton today.
They both have it.
Yeah, I look around, it's like, first I just glanced, it's
Well, the
like,
guys like the dresses there. I do everything.
got French.
I don't know, I do French thing.
I like them over there, they're trying to explain to each other what the hell's going on with fluid mechanics. And Sebastian gets it, he translates it into French for Lucas. It's like,
Conversation,
must be fun of the guys.
yeah, well, we yelled at them a lot because it's like if everybody can't tell what they're saying when they're actually saying. So we try to keep it fully English a lot, but sometimes they don't listen, and we have another French kid. He actually lives in my house. We got two Swedish guys. So yeah, they try to sneak some shirts or some bad words about some guys under their breath, I'm sure.
Oh,
we don't allow the
happens.
language barrier and
Just, everyone learned Swedish and French.
Yeah, with the rafting, it's the same thing. We're all living in the same building. You got guys from like Costa Rica, you got guys from Chile, you got guys from like Australia. I mean, Australia speaks English, but you know, or
Sure, that's what it is.
or yeah, they speak God knows what, some rough English, yes. But you get guys from all over the place. Zimbabwe is another popular place.
Really?
Yeah, we get a lot of guys in Zimbabwe because there's the Zambezi over there that gets rafted.
Really, never thought about that.
Yeah, you go right by Victoria Falls. It's usually like a 5-day trip. It's supposed to be like one of the most amazing trips you can do in whitewater. But it is sketch because the first 2 days you have kayakers with you. And after the second day, they fall off because the crocodiles start getting big enough that they can kill the kayakers. So then you get to like day 4, and then your guides start getting their paddles on the water because they're looking for hippos. And you can't swim unless you're in a rapid because of the crocodiles. So then you would want to swim a rapid because they're class 5.
Put a whole new meaning to danger.
Yeah. But it's supposed to be like one of the coolest like trips you can do in the whitewater world. Well, Victoria Falls is insane as you're rafting next to it.
So what size do we finally settle on here? Anybody got a number?
I'm getting there.
I'm honestly thinking about maybe just like the scope of what we're doing right now.
Well, we're trying to pick some numbers and pick some parts, and components to actually design the shaft.
Okay.
So we gotta go there.
Are we trying to design the shaft and gears, or are we doing the bottoms right now? Like the whole version?
Well, you're at the point right now in the design where you gotta kind of get your head around the whole general picture without the details.
Okay.
So, and that's the tricky part of this whole thing, is how do you start? Well, someone tells you I want to transmit 10 horsepower down this shaft to another shaft to drive this thing. Okay? And the only thing that's going to come out of this when we're done is we're going in at 10 horsepower at something RPMs, and we're leaving at some other RPM. Okay? So that's the whole purpose of gears, it must be a 1-to-1 ratio. What do you got for sense, brother? So kind of what James did here, he started with a 12-inch, right? And then said, well, let's see what that turns out to be. Well, 12-inch, if you divide it by 12, turns out to be, or the torque at 1260 divided by 6 inches will give you a number. And we already set our limit that we kind of like to have the case to be is 12 inches, so we drop down to 10.
Now you got 1260 divided by 5, right? Yeah, 1260 divided by 5 inches, it gives you another number. And then once you kind of settle in on a comfortable spot where you think you got some wiggle room, then we go look for a Boston Gear catalog and pull up a actual gear. And that's going to give us the gear, give us all the details of the pitch. We're going to have a shaft size to put the gear on. We're going to have to know whether we need a key or a ring. Then we'll go size some bearings, and that'll give us some rough dimensions on our shaft. And then we go back and do the actual design on the shaft. That means forces, tangential, radial, and turn them at XY, do shear and bending moment diagrams, pick up all the dimensions, then finalize it, come back with some tolerances, and then go back and see if the gear we chose is actually going to work.
So I've got a 10-inch gear here that looks like it would
Well,
work.
what make and model? Let's bring it up on the screen here.
Let's see, YF100 is the model.
Okay, hold on a second. Where can I go search? Right there.
I just went to, if you go on their homepage, I went to their e-catalog, and then I was able to choose a series of options, 10-inch gear, 100 teeth. So open gearing,
Thing in the front, right?
and then I did spur gears, and then I just selected at the top, pressure angle 20, diameter of the pitch, I chose 10 inches, or 10, number of teeth, I put 100, and then it only gave me one choice for a gear. YF100 there.
Cool. Can we get a mating pinion? So the interesting thing is pitch diameter is 10, hub diameter is 3,
'Cause that's what's
face is
specified
1.25.
in the designer movie.
Okay, that's what I'm looking at right here too.
Yeah. Yeah, it specifies that one's 100 teeth on the main gear and 10 on the pinion.
Is that in the paper?
Yeah.
Yeah, are we like
We're checking their stuff, but we're going to change it if we have to.
okay.
I mean,
We changed the RPMs and set our own horsepower essentially. So far, the changes.
Okay.
so it's cast iron.
Yeah.
Downside to cast iron is
Heavy.
well, it's heavy, yeah, but I'm thinking more about lifespan. So we want 225,000 hours.
Yeah, 25,000 hours under maximum conditions of those RPMs that we set. And 50 pounds eccentric load. Well, that's what the bearings are specified to support, but it should be able to take 25,000 hours at that.
Why can't I get the spec sheet?
Open some sort of new tab. Or something happened.
Yeah, I saw something happen, but where'd it go? Ultraliterature.com.
Oh, that gear wouldn't work anyways. Torque rating.
Well, that's kind of what I'm looking. Well, where do you see the torque rating?
Bottom right specification.
Yep, right there. Okay.
100 pounds max. 300
Cool. Well, So, but you don't have to have 100 teeth. I mean, 100 teeth on a 10-inch gear,
Yeah.
that's really fine. So why don't you cut it down to something like 50? See what happens.
You said you were on 50 feet.
Yeah, we know we're trying 50. Are we changing that for the overall problem, or are we?
Well, we'll see. I mean,
Gives us one choice, but it's steel this time. But it supposedly can't take the torque that we're giving it. It can take the RPM.
well, outside diameter is 5 inches too.
Yeah.
So if we did something, say 80 teeth. They love their nomenclature. Why F80? So it's still cast iron. Only going to get 300 RPMs on that.
Looks like the steel gears are all 600 RPMs and the cast iron is all 300. So it's going to need to be a steel gear.
Specified,
So why don't we do this first? Let's specify the material.
right. What's per year?
We know we want 20. And material is going to be molded Delrin. Cool.
Yeah, it looks like the 52 gear is the highest they go with the steel.
Interesting. So, Boston Gear Catalog was one I always used. Who's the other one?
Master?
Yeah, we could try McMaster.
If you change your diametral pitch, it'll let you go bigger.
Did they put a spec on the diametral pitch in here?
We set one.
Oh.
We set one spec.
Well, I kind of like Boston Gear just from the simplicity of the company, but
You can get up to 70 teeth if you set a 20 diametral pitch, or 20 pressure.
can we set it, do specification on a steel gear without any,
But then it has a really, really bad torque rating, only 160 pounds of torque. Which, that's way under what we need.
okay, what if we did a, I know we were looking at the 20s because that's what the textbook uses, but what if we use the 14 and a half? 24 diametral pitch, 96 teeth, hub diameter 2 inches, pitch is 4. Hey, so let me go back and ask this question. Back here for a minute. You guys remember what diametral pitch is? So, number of teeth divided by the gear. So 10 was our diametral, our diameter, pitch diameter. God, I love the way you twist these words around when you do gears. It just drives me nuts. It always did when I was a student, and it still does today. The pitch diameter of 10, and how many teeth? I mean, is it more than 100 teeth?
What do we decide?
Because you're trying to find a PD that's relatively small.
I mean, so you said either 1 to 10, and you have the teeth at 110.
Right, but I remember our pitch circle, that's where our point of contacts are, or tooth to tooth. So that's what that is. So I guess I'm asking that because when we were playing in here, it just dawned on me. So we got 32 dp. So that's our diametral pitch, but that's the number of teeth around the circle. Not the number of teeth, but it's the ratio of the number of teeth around the circle based on the diameter.
Yeah, that makes sense. It's a 2-inch diameter.
Right. So I mean, most of those when I saw them, I was like, it's these dinky little dumbass things. It's like, come on, seriously, what the hell are we looking at? You can't find a very big surgery. You should be able to find a 10-inch circular pitch gear. But they're giving me the specifications. They want pressure, angle, diametral pitch, number of teeth, and material. So, kind of, we got to get into P little d to get diametral pitch. So sometimes putting in 100 is too much. So literally, what if we did 10? Still looks more about our pinion size. Outer diameter is 2.2. Can I do just show all? And how is that supposed to be helpful?
That's,
Okay, what was the code we got first when it was the cast iron? YF.
YF. Yeah, I'll have to look in. YF 100.
Plastic. Or it's a type of plastic. Delrin is a mixture of nylon and
isn't that what cardboard's made
yes, nylon and polyethylene or something like that. So it's got a little bit harder surface, but it machines really nicely. We used to use it in the machine shop when Mr. Miller was a lot younger. He'd actually mill the boards to hang all the collets in out of Delrin. Probably chunks of it hanging around here. But since his retirement, no one actually is a machinist anymore, so. All right, that's not really going to help us unless we change our RPMs. Kind of see where you're running into this headache?
Yeah.
So, can we change the RPM?
Yes.
There are changed ones.
Well, yes,
Or
we
make
have.
them higher,
We
you
want
know?
to make them,
Well, they got to stay under 300 if it's a cast iron.
but then we have issues with the torque being, too much force.
Right. But we want to limit the force.
Reduce the horsepower.
You could, but our goal is to try to reach some horsepower someplace.
Right.
And granted, I picked this number because you gotta have something, but what can get you to well, if we change it to 8 horsepower, what's that give us for more torque?
Are we using 500 RPM still?
Yeah, I think so.
Okay. That'll drop us from 1260 to 1008. If that was the case, I would probably go down another size. It's 30 meters, go down to 8 inch. Because your weight is lesser, your force is less.
So, in our world, we can do anything we want because no one's really got us locked into a final thing. But in a real design, you're trying to put a delivered amount of horsepower someplace.
So if you had that 10 horsepower motor, we could go in 10 to 8.
Well, we might be able to, as long as we are delivering what's required at the other end of the transmission.
Could we have like a gear reduction to the backwards? Or not a gear
Increase it?
reduction? Yeah.
Yeah. You can actually do that. So they do that really with
linear drive motors are really low torque, and they put them on a small pinion, drive them to a bigger gear, but then change them back.
Right.
That stuff happens all the time. Can't see where we're going here, Matt? There's no definitive answer. There's a lot of guessing at this point.
Yeah, no, I get that. I was confused as if we were like taking like this group did whatever 6 years ago and we were redoing it, or if we were just going through and kind of checking. Especially
Well,
when
I was looking for some parameters to start with.
Yeah, no.
Find a good place.
I'm like a big picture type of guy. Like, what am I going to turn in? Well, what do you want from me? So I like keeping that straight in my head.
Well, right now,
Is important.
what I'm getting out of you is what I expected. Not you personally, but the business.
Yeah, I get it.
You're all kind of, I guess the phrase I'm going to use is compliment.
Yeah.
Because you don't know until you actually decide. I just put a stake in the ground going, that's 10 horsepower and that's all there is to it. I don't give a damn. Find something else. And that may be what you wind up doing. We may wind up, we can't get the gear we're looking for from Boston Gear. I mean, maybe we'll get our bearings from here, but we have to go to some other manufacturer for gear.
Will we have to like custom? Maybe it's
If you have to, I would strongly tell you to go back and contemplate the project again. Because making things custom costs money. And if you're trying to mass produce something, it's not the way to go, unless you are the sole proprietor of that one device.
Right.
Nobody else can buy it from anybody else but you, and you can set your price.
Unless you could find like in-house too, but that's oftentimes out of question.
Sure. I mean, so
Or you can buy
10 horse, okay, so it's an electric motor. Okay. What if it was, we'll pick on Briggs & Stratton, these other here the other day. If it's Briggs & Stratton, they know they want to use a 10 horse motor. What's there? Design my motor for that. How's it gonna work? So, it's really coming back down to looking at the specifications. And truly, if we go up, we're never gonna get there. Okay? But we could drop it to 3 horsepower.
Right.
I mean, for our design. Would 3 horsepower give us a reasonable gear? Okay. More than likely, you want to crunch the numbers and see?
Still 500 RPM.
Yeah. I mean, that's because we're playing with this table.
Right.
Yeah, that drops us down to 378 times the torque
Are we still at
at 500. Yeah.
12? Well, are we thinking 12 for 4 years?
No, we're changing, what did you change to?
That's a 3-inch measure.
No.
Oh, we changed it to 3 horsepower.
3 horsepower.
Yeah, it's
So then when
12 inch
at
axle.
378, when we're trying to find the force, what's our R?
R is gonna be, try 6, well, try
I was gonna, it's
5 to start with and see what it looks like. 10-inch diameter. This is why putting it in a spreadsheet really makes your life easier at this point, because you can just tweak things.
Yeah.
But you're really gonna need to develop yourself a good spreadsheet down the road.
So have you got one of those spreadsheets from when you were working on this stuff, or are you not working on this?
Spreadsheets, my day, when I was working in machine design, were Lotus 1, 2, 3. The forerunner to Microsoft's Excel.
Huh.
It was written by Corel. Corel was going to take over the world and write all the software.
I've never heard
Little
of
did
it.
he know about Bill Gates. No, I don't have one from when I was.
That's fair. Oh, right, so you've been working here for 20
I've been here
years.
22 now.
Wow.
And Excel actually came out of the accounting industry.
A lot of stuff we can do.
So what are we comparing our force to? Now that it's all right, or what are we doing to get that to?
Oh, we're gonna have to get the force, the tangential stuff down when we start doing our shaft design. And it also comes back into play these havoc with your gear. So it makes, you gotta get your force on the gear teeth to make sure that's gonna work. So even though you pick a gear that's known to work, is your force going to work on that gear? You gotta check those. But again,
Tried it with, I found a gear, cast iron still, it's 5 inches with 100 teeth, and it has a max RPM of 600. But its torque rating is only 145, and our torque is 375 inches.
that's 3 horsepower.
That's a good horsepower.
What?
Did they make a gear that actually does this? Somebody does. Let's do this.
So with D10d88c5, that they could use 38600 that you just said. Which are what we have to be at?
Well, if we were using the given RPM, it is, like 378. If you use the 600 from that, it would be closer to, I think, what was it, 140 something? But it's still like way too high.
Yeah, I just saw it.
Yeah.
Use the 3 inches. Or the 3 horsepower. And the 600.
Dude. I hate clicking on ads, but this may be the easiest way to go. New Boston gear.
So the torque rating, what happens if the torque rating is really, really high compared to what we need, but the RPMs are too low for the gears?
If the torque rating's really, really high, it means you can handle up to that torque.
Yeah.
And if our actual torque is lower, we're good.
But what about the RPMs? What if our RPMs are higher than what the gear says it can take?
And that's probably going to lead to a failure.
Okay. Because like, if you go back to that original gear that we found, that's 10 inches diameter with 100 teeth. It has a torque rating of 1,448, and our torque for the system was, had a second ago.
You mean this one?
378.
This is the YF80.
Was it YF100?
Yep.
That's the 80s, but. Yeah, that one. So if we use that one at 3 horsepower, the issue is the RPMs is 200 too high that we have, but the torque, our torque is only 378, and the torque rating on that's over 1,000, almost 1,500. So it's like what, 15 times what we need, or somewhere that
Yeah.
5 times what we need.
5 times what we need.
So would that be enough of a difference to compensate for the RPM problem, or is there a way to find that out? Could we run it at 500 RPMs?
Yes, and that's kind of why I was looking for the engineering data here, because that's the torque rating at 300 RPM.
Yeah.
what's the torque rating really at our 500? That should drop down if this goes up, and that'll be in the data.
Then that means that gear might work.
Yeah.
What if we get, that just annoys me. Every time I click on that, it acts like something does something, but then goes away.
It does the same thing for me. It brings up ultraliterature.com, and the ultra is AL ultra, and then it just closes the web page immediately.
Wonder if they got something blocked here on,
I think the school might.
yeah.
I can try disconnecting from Wi-Fi, see what it does. No, whatever's going on is on their page.
Okay, well, let's try spur gears and McMaster car. They're not much better. Get 100 teeth, but we only got 2 or 3 inch choices.
Just how in the hell did this thing get made?
So at this point, would we
Let's just use that. That's our gear we're really looking for. That one's cast iron too, so.
at this point, would we have to pretty much call one of the manufacturers and get them to send us some spec sheets?
And at this point, yes. I mean, I wouldn't spend all day searching their websites, and they usually have a rep that visits you on a regular basis to try and sell you all their products and make sure you stay reliable to Boston Gear.
Right.
And you'll know the salesperson by name.
And so you'll just be able to give them a call real quick.
So I think we go with, what's that?
Pull out the secret catalog.
Well, it's not so much a secret catalog, but they will, if you send them a message, they will give you back to use this gear. So you don't have to do searching. Fortunately, we, as college, does searching. Because they're not profit by us. Right? They're going to profit by you as a designer to make this part. So let's go with the YF100, and we won't worry about the torque spec, but that gives us that gear.
Okay.
Makes sense? But this is the frustration that goes with doing designs. You got to start someplace, hopefully make some decisions that lead to other good decisions, and down the road. Cool. That's enough for today's torture.
I don't know if you want this or what, when you actually decided when you want it, I'll give it to you now, because
I want them.
I don't want to forget it.
I think it's 24 and 25.
Oh, I put it on.
Online, no, well, I had it done. I just want to give it to them.
Yeah.